Recording in progress.
In this video, we will treat a diode circuit, as I've stated in video 1. So we have this type of circuit. We are asked to determine V out, I1, ID1, and ID2. We are asked to determine them. So what is V out from this circuit? V out is the voltage across here. It's the voltage across here. So what is that voltage? So the voltage across here, since this diode, they are parallel, meaning what their voltage is the same. Remember, we are dealing with a silicon diode. It's practical model. Now, they are parallel, the voltage is the same, which is 0.7. Now, what is the output voltage? So the output voltage, V out, is going to be 0.7 volts. Why? Because our output side is parallel to the diodes, and the diodes, they are also parallel, meaning that voltage across them is equals to 0.7, meaning the voltage across them is the same. So we won't say the voltage across our V out is 0.7 plus 0.7, which is equals to 1.4. We can't say that because our diodes, they are parallel. Since they are parallel, the voltage is going to be the same, and then that voltage will be our V out, which is equals to 0.7. That is V out. So what is I1? So I1, we will focus in this loop. We will focus in L1. L1 meaning loop 1. To calculate I1, we'll focus in L1. So in L1, I first showed you a video on how to derive a formula for a diode in practical model. So the current in this loop, to calculate the current or the formula to get the current in this loop, it's like this. V in is going to be equals to what? It's going to be equals to a VD, which is VD1 plus VR. So what is VR? VR is equals to IR1 times R. So to determine the current in loop 1 and to derive that formula, I've shown in the first video. If you didn't see the first video, please go and watch it. I've explained how to derive the formula. So now we'll just write the formula. So the formula is going to be equals to, the formula for I1 is equals to V in minus VD1 divided by R. So that's the formula for R1. So the formula for IR1, so is V in minus VD1 divided by R. Now let's calculate it. So it's going to be 10 minus 0.7 divided by 330. So it is equals to 28.18 milliamperes. I'll round them to 2 decimal places, but then normalize rounding off to 3 decimal places, which is the minimum. Round off to 3 decimal places to be on a safe side. So it's 28.18 milliamperes. That's the current that will flow in I1. So now, how can we get ID1 and ID2? How can we get ID1 and ID2? So when things share a same voltage, meaning they will also share same current. So these two, they are parallel. And I1, it acts as a total current of these two. So since they are parallel, you know, IR1 is I1 is equals to ID1 plus ID2. Why? Because D1 and D2, they are parallel. Since they are parallel, their current is the same. Why is the same? Because their voltage is the same. And then the sum of the currents through D1 and D2, they must give us what? I1. Why? Because I1 is the total current of ID1 and ID2. It's the current that will enter the junction. And then when it's going to enter that junction, it's going to split. It's going to split to ID2 and ID1. Is the total current is going to split. When it's split, it's going to split to ID1 and ID2. So let me explain why I'm saying I1 is equals to ID1 plus ID2. This is the direction of the current, how the current will flow. The current will flow in these three directions. So when the current flow in these three directions, what will happen? The current will flow to D1 and D2. And then since the current will flow to D1 and D2, D1 D2 will have the current. Now, is the current the same or not the same? So let's see. So Kirchhoff's current law stated KV KCL. Kirchhoff's current law stated I in the current that is entering a junction is equals to a current that is leaving a junction. So now I1 is entering what? A junction, this junction. I1 is entering this junction. Then ID2, it's leaving that junction. So ID2 and ID1, they are both leaving what? That junction. So meaning, since IR1 is entering a junction, it's equals to I out. I out is going to be the sum of the two. So now, if we add ID1 and ID2, they will give us IR1. Why? Because Kirchhoff's current law stated the current that is entering a junction is equal to the current that is leaving a junction. So now we have this kind of junction. We have this kind of junction where ID1 and ID2, they're leaving what? A junction, and I1 is entering. So this is going to be ID1 and this is going to be ID2. So ID1 is leaving, ID2 is leaving. So what is I1? I1 is equals to I out. So I in is equals to I out. So what is I out? I out is the sum of these two. They're going to give us what? I1. So formula for I1 and ID1 and ID2. So that's how we can get it. So now since the sum of the two, ID1 and ID2, they will give us IR1. So what is ID1, ID2? Simply I1 and ID2, we're going to say I1 is equals to ID2 is equals to I1, IR1 or I1 divided by 2. So they are both equals to, if we divide 28.18 by 2, the current will be 14.09 milliamperes. So how the first thing you must check before you answer this kind of question, before you answer it, check whether your diodes are in fault bias. From there, then you can start calculating. Then when you calculate, be able to draw a direction of current. You must know how the current will flow. So now in this circuit, the current will gonna flow in that. So to get ID1 and ID2, you must know how the current will flow, and then you must also know an KCL, which is Kirchhoff's current law. Kirchhoff's current law, KCL. Kirchhoff's current law. Kirchhoff's current law states that I in is equals to I out. So how did we get ID1 and ID2? We simply know, since the I in is equals to I out, what is the current that is entering? It's IR1. Then what's the current that are leaving? Meaning the sum of them, they equal to what? IR1. So we simply divide the IR1 divided by 2. So current was gonna flow in this three direction. So we answered V out, I1, ID1, ID2. For this question. If you understand and if you learn something in this video, please subscribe and share with your friends. See you in the next video. Thank you.